So the next thing I want to do is the same scenario as above. With replacement, what's going to happen is we'll select a marble first, so that'll be probability 3/10 that it's blue, 7/10 that it's red. Not much more to say there, same as before. We put it back. So the probability that the second one's blue is also 3/10. The probability that the second one's red is also 7/10. And then likewise 3/10, 7/10. So that is how that's going to work. And then if you wanted to find the probability of R2 given B1, what you could do is you could look at what's the probability of R2 given B1. Well, that's going to be based on our formula. That's going to be the probability of R2 and B1 divided by the probability of B1. And that's going to be, let's see, R2 and B1 is going to be the product of these probabilities going in that route. So that's going to end up being 3/10 times 7/10, and then divided by the probability of B1. The probability of B1 was 3/10, and so we're left with 7/10. And I want to notice that that 7/10 is actually just the probability. This is the probability of R2 given B1. And let's do one more calculation here. So this will be the same as before. What's the probability of R2? And so again, there's two routes to get to R2. You could go through B1 or you could go through R1. And so this is going to be the probability of B1 and R2 plus the probability of R1 and R2, just like before, same reasoning as before. And that's going to end up being, let's see, B1 and R2 is going to be 3/10 times 7/10 plus the probability of R1 and R2 will be 7/10 times 7/10. So that's going to work out to be 21 over 100 plus 49 over 100, which works out to 70 over 100, which is 7/10. And then I want you to notice that these two probabilities are equal. The probability of R2 given B1 and the probability of R2 are equal. So what that means, let me rewrite this so it's a little bit more legible. So what this means is that R2 and B1 are independent events, because knowing ahead of time whether the first marble was blue or not did not change the probability that the second marble was red. In the prior example, the events were not independent. And I think intuitively that should make sense. If we put the marble back, then it really doesn't matter what happened first. That won't affect what happens for the second draw. Okay, so in this case, when we do this with replacement, R2 and B1 are independent.